Alain Lioret is a professor of image arts and technologies at the University of Paris 8. He teaches 3D programming and procedural generation techniques. He's a specialist in generative art. His areas of research lie at the frontiers of art and artificial intelligence. He's been working for around 10 years on the artistic perspectives that quantum computing can bring. He'll be presenting from cellular automata to world models, alternative trajectories of AI. Very good to see you, Alain. Please go ahead.
Okay, hello, Matt. Thank you. I will share my screen. So where it is? Sorry. This is this one, I think. Yes. Yes. Okay. So where it is? I think it's this one. Yes. Okay. So thank you everybody for the invitation. So I will try to make a speech about my work in AI and teaching AI for students, but in another trajectories, I think, because I use an alternative trajectories of AI since 20 years with my work, and I will explain this to you now. So. Why this matters for art and design education? Because today the dominant narrative is the current discourse frames. AI in education is almost exclusively around generative AI. We speak about LLM, diffusion model, ChatGPT, Midjourney, and so on. And this is things very important. I have to excuse. Sorry, but I have to. You have to mask not up, not this thing, because it's difficult for me because I don't see my screen. Okay, it's okay. So this framing creates a pedagogical problem, I think, of course, because students now seems to become prompt operators, not creators. AI is positioned as a replacement for artistic expertise sometimes, and the result is that this symposium calls A slope. So there is an alternative trajectory for me, older, deeper, but also newer. I explain you just after, and so I try to speak about something very important for me, not so new, but someone are like world models now. I'm using since 20 years ago, I think, cellular automata and emergent systems in my work and in my teaching, but also genetic algorithm and quantum computing since many years. And now my future, I think, and my present now is to work with world models. I will explain just after, because I prefer that the students is not a user of a system, but there are some designer of conditions for emergence. Emergence is the very, very important word is here, I think, so for me. So in this presentation, I have four parts, but I don't speak about the third part because it's too long, I think. But the first part, I will explain the Bing series that I have begins more 20 years ago. And it's very important for me because it's my research work, and I'm using it in my teaching also in Paris 8 University. And the importance here is about emergence and not about statistical generation. It is why I am using since many years cellular automata, genetic algorithm, quantum computing. And finally, I will explain how I am very interested by the world models. I think it is very important because they are the next trajectory for me, and it's one of the main important of this is Yann LeCun, a French man and people who is making some kind of system about world models, and I think it's very interesting. So first, I will just explain what I have done since 20 years ago in my research and my teaching, of course. It is about the being series. It was beginning with painting beings 20 years ago and so on. I used just some old algorithm, but very important for, I think it was cellular automata, L systems, neural networks, and that will be very important for emergence, I think. Then some years ago, I discovered quantum computing, and why quantum computing is very interesting with qubit, because it can bring us some new creative space. I will explain just after. I work with quantum beings, and also I transform my old cellular automata, for example, with quantum cellular automata, which was very important. And I continue this work, notably this year with live beings. I just last week I was in Toulouse at Evo Musart conference. It was very interesting because I was explaining the emergence synthesis with live beings systems. So I have to go fastly because I have made so many things here. But the first work was about painting beings, being paintings. It was the first one of my systems using four important algorithm about artificial life. It was about cellular automata, L systems, neural networks, and genetic algorithm. I am teaching all these algorithms to students because they are very, very important for the emergence, and it is very important. I was published here at the SIGGRAPH and something like that. So it was very, very important for me to do this. So here are some, for example, some little picture I've made 20 years ago about the painting beings. And after 10 years ago, about 10 years ago, I was discovered for quantum computing. Why is it interesting? Because quantum computing can expand the emergence possibilities. We can use more things and more possibilities with some very important things like, for example, here, superposition, entanglement, interference, and measurement. All these things are very important because they can explode and expand all the creativity possibilities, and we have more and more possibilities to make some emergence and some bigger data, but without using LLM, without using a large scale of data, but just using some algorithm and just using a new kind of algorithm, a new kind of possibilities to make some emergence. So I begin to make some very interesting work with this, like quantum cellular automata. Here are some pictures I've made with this about 10 years ago, and it was very important. And this year, the work is continuing, and so I make a new kind of thing like this. It's about the live beings. I just presented as I say, last week I was in Toulouse, in France, and there is a very, very interesting conference called Evo Musart in France. And it's the next thing I am trying to do with always quantum computing and something like for novel forms and emergence possibilities. Here are some pictures done with the last systems of live beings I just present last week. So I think for me the important things here is the emergence and not the statistical generation, because when we speak about creative AI in education, all everybody thinks, of course, of LLMs with ChatGPT, Midjourney, Sora, and something like that. But I am more interested by the truly creativity. So, for example, when I use some cellular automata, genetic algorithm, quantum computing, I try to get some true novelty and to expect to get some unexpected and unprecedented works made by students or by me, but also by students using this kind of algorithm. It is very important for me to do this. So one of the first things I've done with this was about cellular automata, because cellular automata are old, as you know. The first time they are more than 50 years made. And for example, the Game of Life by Conway is old. Is an old thing. But one of the things which was very interesting for me about 10 years ago, it was about using quantum computing with cellular automata and to make quantum cellular automata to make an extension like this. And of course, we can make some very, very, very interesting like for this, because here cells are qubits now. And qubits, if you know a little about quantum computing, are very interesting because they are made, they can be in superposition states and entanglement states. So we can have more complex amplitudes, and it is very, very interesting because it is an exponential possibilities of creativity. It is very as I say to my students always, when you have just 50 qubits, 50 qubits is not so big number, but 50 qubits is about two exponential 50 possibilities. It's enormous. So it is very, very interesting. So here we can see a very first work I have done with this, which was made with Gaëtan here, the students at Marne Valley at the HIMAC. We have made a project. It was a quantum cellular automata. It was a very interesting project. And we have worked with some students to make something to play and to try to make an experiment with quantum cellular automata. For the students, it was very, very interesting. So as you can see here, you can see some cats, some Schrodinger's cats, dead and alive. So yeah, it was very funny experiments, and I thought the students were happy to do this. One thing more is, of course, using a genetic algorithm and also bio-inspired neural networks, because I am using so far from 20 years ago. I was very inspired by Matt Lewis, which was here because I found his work about genetic algorithm to make some evolution with humans and shaders and something like that. And I remember that when I was doing my thesis, I found the work of Matt here, and it was very, very interesting because he works like with the same software like me as Maya or Houdini, and he was made some very interesting projection with genetic algorithms. So I work with them, and I think it is very, very interesting to use them. So I use them. And I was inspired by other artists like William Latham, for example, or Carl Sims, because they have made some very, very interesting work here, of course. So why I say all these things to you? Because the question for me is about the LLM creativity. So I think the LLM can do some things, and of course they are very interesting. I am using LLM also in my work because they are very, very interesting. But I think we can think about some paradox for teachers, because as I say in this slide, I think we can ask us if they cannot invent a radically new style, if they cannot produce a work that surprises itself, if it does not understand why it produces what it produces and it teaches students nothing about the mechanism of creativity. So it's very, very important for me. And if I've made this little sheet about originality, predictability, student role, and something like that, I prefer the second way using the other algorithm. So I don't speak about this because I think it's too long about because I am using some things like that. It was for another presentation, and I think I will give it if you want because it's very important. One of my very important inspiration was the Creature games. I don't know if you know these games by Steve Grant. It's an old game, but it was a so intelligent game. People don't understand, I think, how it was also important with genetic algorithm, neural network, and autonomous system. It was so intelligent to make this system for creatures. I think the norm. If you know, I think the people here they are too young, don't know this this game, but I know it, and Steve Grant is a genius for me because he is very important. So now, what I am doing now, because now of course you can say, oh, genetic algorithm, cellular automata, they are old systems. Okay, why not? But I'm using, as I say to you, quantum cellular automata, quantum genetic algorithm, and so on. But there is a very new way, very interesting, which is guided by Yann LeCun, which was a co-inventor of deep learning and Turing Award winner. He was working for Meta at Intelligence Artificial for Meta, but he is now making a new society on Paris, around the world, which is called AMI, and he is working about new kind of intelligence, artificial intelligence. It is about the world models. And the world models are very interesting because they are like my beings. So because they are working with the interaction with the world and not only with a statistical prediction of text. So it is very important for me. And he has made a very new architecture, which is called JEPA, Joint-Embedding Predictive Architecture. You can find some literature about this. Since 4 years ago, he has made this. I think it's not so new, so well known for now. And JEPA is a very different thing because if you compare to the LLM system, JEPA world model are working with video, audio, sensor, spatial data. It's very important for us for artistic teaching and for artistic creation because they are not working with text but with pictures and something like that. So it is very important. And in the learning, they try to make some representation and to use some implicitly learned physics, like physics world. So I think it is very important, but it is very complicated to do. Also, of course, because it use something very difficult. And the JEPA model use some video, something like that. So it's very hard things to do. Perhaps you know some other system like this, like the Google Genie 3. We cannot have a Genie 3 in France, unfortunately, but you can in the USA. But Google, because Google have made a world model very interesting with Genie 3, and we cannot use it in France, but it's very interesting to do something. And I think very important for me here for art education system that understands the rules of the world can also be a system that knows when and how to break them creatively. So I love this new kind of AI, which is so new and not so performant, with not so great performance now because we have to do some job and so something like that. So the JEPA system is, I think, a pass. It's not me which was working with this picture, but it is a path towards autonomous machine intelligence. So I think, yeah, I'm very interested by this kind of systems, and so I think for me we can use the world model like next teaching frontier, and I am very happy because I think there is a convergence between my research and the world model. And if you read my papers about beings, live beings, quantum beings, painting beings, and so on, you can understand how they are like something like the world models. Because I am using some kind of algorithm and some works working like this. I don't know, it was like a world model, but it is. It is I think beings can be seen like an old, very, very old world model, for example. So yes, of course. Conclusions. Conclusions for my speech now. So I am, as you understand, I am using alternative trajectories for art and design education. 20 years of research for me are important because the main things important here are emergence. I am very, very impressed and interested by the emergent systems, by the true artificial creativity. So it is very important for me. My Being series since 2002 is very important because it was always working with this kind of thought in the mind. And I am very happy because Yann LeCun now with more model is in this kind of things. So now I am my research now and perhaps my future teaching, not yet because I am not ready, but my future teaching, I hope, will be with some world models. And it is very important for me. Here are some kind of references from but you can find many of my papers in Google Scholar, for example. And of course, Yann LeCun papers are very important for me now because they are working like this. Okay, so thank you for listening. I think the deepest artificial creativity does not imitate, it emerges my important thing. So thank you all for your attention. Thank you.